Alright, we're going to take a look at the effects of outliers. When we talk about data, outliers are numbers that, when we look at them, they're different. If you go on and take more advanced statistics, you'll find out ways to mathematically determine, what should and shouldn't be an outlier and how close together everything has to be. But we can, just by eye, look and often detect outliers. We've talked about them with Wayne Gretzky's point total in the years when he was in the NHL being head and shoulders different from everybody else. And we can see that sometimes where it's a legit outlier. Other outliers are caused by mistakes in data collection. Um, some outliers are just as important as the other data values. Now, we've got to remember, when there are outliers in a data set, the mean, median, and range can be different from what they are when the outliers are removed. People who work with data need to decide when outliers should and should not be used when calculating measures of central tendency. So let's take a look here. Shannon practiced shooting baskets every day last week to prepare for a basketball tournament. She recorded the baskets she made each day out of 25 shots. So 14 out of 25, 17, 16, 20, and so on. What is the range of baskets scored? So again, if you remember, range is going to be the positive difference between the biggest and the smallest number. So I look at my biggest, looks to be 22, my smallest is 5. So my range is going to be 22 minus 5. So 11%, better now. 22 minus 5, which I can do in my head, but 17. What are the median and mean numbers of baskets scored? So, median, I got to arrange these in order here. So, 5. Okay, that one's done. I'll just put a little tick next to the ones that I've done. 5, my next smallest looks to be 14. No 15, but we do have a 16. 17, yep. 18, yes. No 19, but we have a 20. And a 22, there it is. And now median, I am simply going to look in the middle of all these. So, middle of these 7 looks to be my 17. Alright, now, I think it's pretty obvious 5 is potentially an outlier. Now, question that we could ask is, what if we got rid of it just for a moment? Does that change the median a whole bunch? Not really. Median is 17. If we got rid of this, it becomes like between 17 and 18, so 17.5. Doesn't really change the much. Let's look at the mean. So again, mean, remember we add them all up and then divide by however many they are. So in this case, the mean is equal to 5 plus 14 plus 16 plus 17 plus 18 plus 22 plus 20 plus 22. Okay, so I'm going to add them all up and then divide by, well, there's 7 days in the week, so divide by 7. So 5 plus 14 plus 16, and I'm purposely kind of drooping this down below, plus 17 plus 18. Unless means are very small numbers, this is a calculator kind of a thing usually. Plus 20 plus 22. Do all of that, and then I divide the whole works by 7. So my mean, add that all up. 5 plus 14 12, which needs to be divided by 7 yet, because I didn't do that all in one step. Divide that by 7, and I get 16. So median 17, mean is 16. Not too terribly far apart. Alright, oops, so now move down a little bit. And identify any possible outliers. Well, we kind of did that already, and that's this Thursday total, number 5. Should that outlier be removed from the data set? Explain why or why not. I think in this case it should not be. It doesn't look like she's made a mistake. It just means that Thursday was a bad day. Maybe she was tired. Maybe she had a headache. Maybe she had a bunch of homework and that was on her mind and she just wasn't thinking about shooting. In this case, I don't think we should remove it from the data set. All right. So, moving on to the next page here. Science experiment, students were asked to measure the length of their right thumb from the first knuckle to the end of their thumb. This table shows the lengths that were measured by 10 different students. So student A, B, C, D, E, F, G, H, I, and J. Those are all my different students. Now, as I look at them, I'm going, Student G seems to have a rather big hand. So when I look at part C, and I'm skipping ahead on purpose, I'm going to answer A and B, leaving that one in there. But I think somebody made a mistake. I think this should have been 3.1, not 31. But we're going to figure it out. So range, again now here, range is biggest minus smallest. So 31 minus, anything smaller than 2.7? There, 2.6, there it is. 31 minus 2.6 should be equal to 28. So the range is 28.4. Median and the mean. So again, median, I'm going to line them up in order. And then find the middle one. So I can tell you that the 31 is going to be at my big end of things. 2.6, that's gone. 2.7. 2.7 again. Seven is done. Next is a couple 2.8. Oh, 31, that's not 3.1, but here's a 3.1. Lovely, I have a 3.2. And finally, I have a 31, which, like we've already said, probably doesn't belong. 1, 2, 3, 4, 6, 7, 8, 9, 10. Oops, sorry. So it's going to be between 5 and 6. 1, 2, 3, 4, 5. No, sorry. 1, 2, 3, 4, 5. And here's 6. So my median is going to be halfway in between 2.8 and 2.9. So median is going to be, sorry, 2.8 and 3.0, which will be 2.9. And then my mean, again, I add them all up and divide by, in this case, 10, however many that there are. So let's do that real quick. 2.6 plus 2.7 plus 2.7 plus again, 2.6, not hit the wrong button on my calculator here, plus 2.7 plus 2.7 plus 2.8 plus 8 plus 3.0 plus 3.1 plus 3.2 plus 3.3 plus 31 equals 57.2. I divide that by, there was 10 numbers here, divide that by 10. And my mean is 5.72. These are two significantly different numbers, right? 2.8 times 2 is 5.8. So it looks in this case like the mean is affected much more than the median when we're looking at this one. All right, so now we talked about this. Do you think should the outlier be removed? I think it should be. There is not a normal human who has a 31 centimeter distance from their first knuckle to the end of the thumb. Okay? This is obviously, or quite obviously, a mistake. So it should be removed. How would it affect the median and the mean? Well, if we get rid of this one, the median doesn't change all that much. The median, I think, if you look at your list of numbers and get rid of that one, now becomes 2.8 instead of 2.9. The mean, on the other hand, is going to be significantly different. So whereas the mean earlier was 5.72, if I get rid of the 31 out of that data set, my mean becomes 2.9. Okay, 2.9 is right in the midst of this, and it's very close to the median. So how would removing the outlier affect the median and the mean? The median, oops, not the median, the median is not affected much. The mean is reduced a lot. From 5.7, down to about 2.9. All right, so that's the effect of removing the outlier. That's what it does. All right. So your job here, do the show you know. Okay. We will look at that when we get back. On my video, the assignment moves to where it's not supposed to. On your page that you've got, it's where it's supposed to be. Have fun.